And I know for sure that I looked with y'all at the scoring of if it's essentially correct, partially correct, and incorrect. We looked at that piece, right? Okay, so that's how we score on the AP exam. Each section is either essentially correct, partially correct, or incorrect. And so there's a clear rubric associated with it. If you want to watch the video, you can go back and watch it. What I did not cover last time is I should have shown y'all this as well. At the end of all of this, there is a way to determine what you score as well. So, if it is a complete response, all three parts are essentially correct. That's what earns you a 4. It's hard to get a 4. That's why there's that scaling in there. A substantial response is 2 parts are essentially correct and only 1 part is partially correct. That sometimes changes, right? To get a 4, all 3 parts have to be essentially correct. Sometimes 2 parts essentially correct, 1 part partially correct here. But sometimes there's 4 parts and you get 2 parts essentially correct and 2 parts partially correct, things like that. So it changes a little bit, but that's how we score it. Now you can score a 0. If you don't even have 1 part essentially correct and 2 parts incorrect or 2 parts partially correct, then you do get a 0. But everyone can get at this bare minimum. What you really want on the AP exam to be shooting between that 2 and that 3. Obviously on test in this class, you want between that 3 and that 4, okay? So, but that's why we did some practice with it. That's the only thing I'm really gonna talk about with that. The last thing I will note is this. I do want y'all to remember, does your learning ever actually stop?
No.
No. I believe, I'd have to go back and check the syllabus I gave you, but 40% I believe comes from your test, but 35% does come from your proficiency scales. And so I'm going to look at your DYUs, I'm going to look at your test and determine, do I see proficiency out of this? If you don't master it and show me proficiency by the end of the test, guess what? Come in and let's sit down and let's talk about it, let's develop your proficiency, and you can still earn proficient on that proficiency scale, which is worth almost as much as your test grades. So everyone can still be okay. And for those of us who struggled on the first DYU, remember, I'll replace your DYU grade with your test grade. I won't always do that, but because I know some of us are adjusting and learning how an AP class works, I'll account for that. And also, just the first DYU for a new teacher is always wonky for some people. Okay? Yes, Jaden.
Where does the 15% come from?
Was it only 15%? It's got to be higher than that, so I need to readjust those. You also have projects. Ooh, thank you for reminding me of that.
Oh, can we do a presentation?
My bad.
No, we will be doing presentations.
Wait, why not?
I am not presenting.
No, because if we have like a presentation about like observational studies, I would love talking about that.
We still have to do the Go project.
I can make a
Okay, can you make sure?
I mean, it's a small class.
I'm sure we can knock it out.
I don't care.
No, it's not the people, it's the, I don't want to sound like an idiot up there.
I want to watch it
It's
too.
okay,
Alright.
I sound like an idiot.
So, here is one way that you are actually going to show proficiency with study design as well. I went through and I picked out 2 different studies. One is it's a lot of reading. I'll clarify some things soon, okay? Stay calm.
Oh
So-
my gosh.
January 31st.
Yes, that gives you over a week.
These are studies.
So, also, I think it says on there that the rough draft is due January 31st. Because I'm going to give you feedback before your final draft. Okay? The rough draft is not going to be worth as much as the final draft, but you need to get the rough draft done. Now,
That's how I do it.
what I need y'all to hear me on is, I've given you 2 different studies. These 2 studies are actually super, super interesting. One of them is Stanley Milgram's study on obedience. In that study, Stanley Milgram looked at how in the world do Nazi soldiers do the atrocities that they did, and looked at the issue of, because a lot of them claimed, well, I was just following orders. And so the question is, well, does following orders really explain why people act this way, right? And so it's actually a very, very interesting study, very relevant and important to realize. And I will also say a study like that would never be done in today's world because, well, it is super unethical. We will probably look at something called the Bobo doll experiment later this year, or the Stanford prison experiment, right? So these are some wonky, crazy things.
I love
that going, yeah. So crazy, wonky things that we need to be aware of. And so what I'm asking you to do is read this study. Oh, and then the other one's really good. That's all about delayed gratification, right? And how delayed gratification at a young age makes a prediction for success later, right?
I'm so
Okay?
tired of success,
So,
bro.
this is cool stuff, it's fun stuff, it's real, but here's what I need you to do, and it's in the instructions so you can see it later. I need you to read the studies, and I'm going to give you all time on Monday to ask questions, so that you have a little bit of time to read it and start thinking about it. Read your studies, and then identify what type of study you think each is. So you need to say, hey, this is an experiment or this is an observational study and here's my evidence why. So you need to think about what are the goals of this study, both like in statistical terms and in the terms of the actual study. They should go together. I need you to think about what was the issue in the study. So like, were they needing to reduce the effects of bias, or were they needing to reduce the effects of confounding? What did they actually do in order to do that? Did they use random assignment? Did they use random sampling? So you need to talk about those elements of study design. And the most important part is this. What would you do to improve the study design? And so identify ways that they could have done things better. What were things that they could have done to reduce confounding? What were things they could have done to reduce bias better? Right? And if it was an observational study, do they really need to worry about confounding? Or would it still be good to worry about confounding, right? And be able to make an inference about cause and effect as well. So those are things to consider. Again, by the way, next Friday, is that your final paper? No, I want it to be next Friday, your rough draft, so that over the weekend I can give you feedback before the final draft is due. Okay? Yes?
How do you want this set up?
Like, what kind of formatting?
Yeah.
Essay?
Like MLA or APA?
So
that what
you
you're
want
asking?
you want like a
Is that-
Essay.
So you want essay?
Yes.
okay.
How many paragraphs?
You need to answer the prompt.
So do you want like a thesis?
I need a format.
Do you need like a thesis with like both experiments and a body paragraph about one experiment, a body paragraph about the like say observation?
I will say this. If I were you, I would focus on it thematically, not study. Meaning, I would focus on comparing and contrasting the types of studies and their goals, right? And then maybe another section. I wouldn't necessarily do one paragraph, but I would do a section where you compare and contrast the two studies and say, okay, this is this type of study because of blank, whereas I know this one is this type of study because blank. And then go into, okay, so this is what the goals were, or this is what they did in this study to reduce bias, whereas in this study they did this to reduce confounding. You honestly though can write it however you want as long as you answer these prompts.
Okay.
Okay? So there's not one right way. I'll share with y'all tomorrow, I'll print it out, share with you tomorrow, an example of what an excellent one was from the very first year I did this. And just so you can see an example, she
How
was
many
the
years have you
valedictorian
taught?
of that year. Huh?
Oh, sorry. How many
Was it
years
Morgan?
have you taught?
Morgan Taylor?
Baby steps.
No, this is years ago. This is year 5 or
It's
6.
gotta be one of the
Oh,
champs.
wow.
So, I mean, you have to remember, I did it twice at Tuscaloosa Academy, and I've done it 3 or 4 times here.
You have?
Oh, are we still talking about the test too? 'Cause I
You can ask questions,
I
yes.
wrote-
Yes, do you have a past test we can see? No.
Why not?
But like, it would be such a good study method. If you have, like,
So,
a
you know what I have given you that would be good study methods?
Right.
The FRQ.
So, I've already given you old FRQs that are very similar. I have also assigned progress checks,
Oh, there
which
is.
have multiple choice questions that are very similar. So you need to remember, like, if you want old questions, like, I think, I could be wrong, but can't you do a progress check more than once?
No.
No.
Do I think I could reassign it though,
Yeah,
you
you
could.
can. You can.
But
do
you
that, we
can
don't.
also go in and look at the answer you put and what the correct answer is. You can do that, can't you?
So are the progress checks you assigned required?
What if we just go back to like?
Yes, progress checks will always be required.
Oh my god, I have so much homework.
You've already done them.
Oh, okay, never mind.
Assigning a new
I thought you were
one.
assigning new ones. I was like,
No. I'm talking about the observational study and experiment progress checks. I'm saying you can use those to help you study. Like, you cannot get multiple choice more similar to AP style questions than the progress checks that College Board created.
So they're gonna be that light?
Well, progress checks are
Yeah.
lighter. Remember the bio test?
Yeah?
Progress check is pretty easy.
So-
No, it's not.
Yeah, it was.
Okay, but here's the thing, you also need to remember it depends on who you are. Different people have different struggles, but those will be their DYUs will be a very useful resource to study. Your Frere models will be really useful to study if you didn't turn them in because you weren't here on Friday. You make sure they're complete and you turn them in tomorrow. Sound good? Okay. Actually, everyone will resubmit your Frere models tomorrow. Please look to see if you should have added anything as a part of your studying.
I don't know.
So how much editing do we make?
I mean, just look at the feedback I gave you,
Oh.
right? Like address the.
Some are like questions and I don't know.
So like if there's an area of concern where you're like, ooh, I probably should add this in because this will help me study for the AP exam, then add that on there. I'm not saying you have to make a million edits. I'm saying that look at the feedback I gave you because that may be something that you're missing to prepare for the test. By the way, don't forget, Michael, you also have the proficiency scales that tell you exactly the skills and the vocabulary you need to be successful. Huh?
All of it? All of it?
Well, here's the thing, it's really hard to do the skills if you don't have the vocabulary down.
I'm saying like, does it have all the vocabulary on the proficiency?
I believe so. I might have missed something, but I don't think I did. Yeah, I don't think so. You got this line. Alright, so let's get back to studying one variable data. Ma'am, oh, were they not in there? No, you're talking about the free response that went with the scoring guidelines? Was it not in there? Hold on. They're in here. Right here. There's the actual questions. And then these are the scoring guidelines for them. Yeah, so it's 4 questions total though. So 2019 number 2, 2016 number 3, 2019 number 2. Wait, are those the same? No, these
Oh my god, you trashed that.
You did?
Okay.
Like I was.
If there's something I'm missing,
about, like,
there you
the,
go. But also remember, I emailed them to you as well.
I remember.
Alright, sorry, we gotta get started though. One variable data, I know I talked about those studies, but again, this project, I know the rough draft is due in just over a week, but you gotta remember it's unfortunately a block that we're on, and 2, that's just a rough draft. The rough draft is not a huge part of your grade, but the better you do on the rough draft, the less you have to do on the final draft. And the better you do on the rough draft, the better you attempt on the rough draft, the more feedback I can give you. But again, I'll show you an example from last year tomorrow. Alright, hey there, see, even if Jaden didn't remind me of the study design project that I already had in the agenda. But go for it.
Why, so is it only the AP exam that's like partially, essentially, and incorrect?
I think AP Stats is the only one that way. AP Calculus, right, for those who don't take calculus, there's 9, are they still doing the 9 points and you get points from different pieces?
She has not told us any of that.
That's how it used to be, I don't know if they changed it or
We
not.
haven't taken the first test yet. We only had like homework checks.
Gotcha.
Tomorrow's the first test.
Okay. Alright, so Unit 2, one variable data, we're going to finish up categorical data, and then get into quantitative as far as possible. So I showed you all this yesterday. This is the proficiency scale for Unit 2A. It's all about categorical data for the most part, and this part of the lesson from Skew the Script is going to tackle all of this. On most of this, y'all saw, y'all saw in those notes, again, I'm sorry, my bad, I screwed up. I forgot to check, did you get yours re-uploaded?
I got them. I was copying it down to my phone. So you can
Gotcha, I got you. Just upload them to the school so I can see them there. Okay. Alright, so all of this is what we're covering. The only things we're really not covering are, in this part of the lesson, is the shapes of quantitative data graphs. But for the most part, we can get to the rest of it. Describing categorical data. By the way, if I get to something and I forget to cover it based on the question y'all had yesterday, let me know, but I think I've got everything. So, remember we got graduate students 1973, and what was the problem we were seeing?
More men were being
Discrimination.
admitted than women.
Yeah, more men were getting in than females, right? So, that was discrimination there, and so we said, all right, we gotta investigate this, right? When we see things, we investigate it. So, were Berkeley's admissions biased? So we started looking yesterday at marginal distributions within two-way tables, and that helps set things up. Please notice, two-way tables are all about categorical variables. One thing I saw in the book or somewhere recently that I think is a really good note is, you can actually make any quantitative, what was that?
Traffic lights.
You can't see that?
No.
I mean,
I think
maybe
we have
I
that.
see it.
I know back there.
Okay.
Good.
So, any quantitative variable can be made into a categorical variable. The reason I say that is, for the most part, quantitative variables are quantities, right? But are there times when you want to look at a percent of how many fit in, how many you have of this one number? As soon as you convert it to a percent, we're talking about categoricals. So quantitative are things you're going to find the mean of or the median of those values. The categorical are going to be the things you're looking at percentages of. All right. So categorical, gender, admission decision. Remember, those were our two categories. And then we got to these totals here. And so if I'm only looking at gender, right, and I'm only looking at this one variable, what are these relative frequencies going to be called?
Marginal.
Marginal distributions, right? Marginal just means that we're looking at the margins. We are only looking at one variable, okay? So when we say marginal distributions, we're talking about the margins. We're only talking about one of those two variables. There it is. Male and female. Okay? So, again, remember, I will note, I'm going to move quicker through these things because y'all did do notes on these during the weather day. So, but if you need me to slow down and re-explain anything, please do. But I do record it. If you want to write some of the stuff down, you can, but again, don't have those notes. So marginal distributions, it's the margins, it's only looking at one variable. So do notice, if we're just talking about people that are applying, who's applying to UC Berkeley more regularly?
Male.
Males, right? So could that be part of the explanation for why there's a higher acceptance or more males accepted?
A little bit, but not like fully. It's only 10%.
Yeah, right. So when you say 10%, what do you mean?
Like it's only the male population is only around 10% higher than the females.
Look again.
It's close to 20, right? Like,
I'm gonna say that's pretty darn close to 20,
yeah,
almost
close to
60,
20.
I can't
almost
see.
40. You're kidding.
Oh,
But
sure not.
okay. So it's about 60-40, right? So there's a lot more males that are applying. So that is something we should pay attention to. So we can't just say, oh, more men are making it in than women. Well, more men are applying as well. But let's investigate this data a little bit more. So more male students apply. Is this the reason for the gender gap? Well, let's look at another type of graph. So remember, okay, males were 60% of the applicant pool, females were 40% of the applicant pool, but what percent of the admitted students were male?
68.
So does the higher percent of applicants explain all of this difference?
No.
Okay, so maybe there is still some discrimination, right? That's what we need to investigate. Okay, so let's use what's called a side-by-side, and you'll hear me say bar chart, bar graph is fine, but usually chart is what I say when we're talking about categorical. So notice, literally just side by side, we have all of our applicants, and we have male side by side with female, admitted here. This is not the type of graph that I would use. Does anyone remember another type of bar chart that you could use in this context?
The ones where they, the mosaic thing?
So mosaic plots are really good for maybe the, what am I looking for? Two-way, for the entire two-way table. But notice, this is all applicants, right? So that's only one variable really, it's just the gender.
Maybe like putting them next to each other. I forgot what it's called. So like.
Stem plot.
So stem plot will be quantitative.
No,
We're
so
going to
like, so like putting the both genders next to each other, like male and male next to each other, then.
So that could be a comparative bar chart. This is another type of comparative bar chart, is know what that's called. But what if I were to take this piece right here and shift it to here?
No.
Does anyone remember what that was called?
No. Wait, what's it start with?
An S?
Never mind. Segment. Actually?
It's segmented, right? It adds up to what, 20% here?
100?
Yeah, if I take this and I stack it here, that's 100%, isn't it?
Yeah.
And I've taken that 100% and broken into different segments. Personally, segmented bar charts are a really good way to compare data like that. That's probably what I would do. I wouldn't use a mosaic plot because it's not it's not the two-way table, it's not all of it in the entirety. Now, okay, I have no clue. So this is one of the few things that I completely dislike that Mr. Young-Saver does. I just feel like this makes things a little bit harder than it has to be. Here's what I want you to remember. When you make a graph in statistics, you got to make sure you use the right tools. When you make a graph, you got to make sure that you use the right tools. Okay? So,
That's not how you spell tools, Mr. Kenny.
Yeah.
No?
I don't know if you noticed.
No.
I don't know if you know this, but there actually is a pin that's called what again?
It's a tool pen, it's the best pen you'll ever use.
Second
It's
off,
just like that. What's a
This
tool
tool is the title of the graph. You got to make sure you have the correct
That
units
looks
for
like
your
how
graph.
some people say
You got to make sure you label your axes.
tools. Tools.
Oh, a pen. I think it's a.
Get my tools.
I have
And you
one
got
of
to
those.
make sure you
I stole it from my
scale
band teacher.
your axes.
I just steal it.
So, if you are going to make a graph for me, right, you've got to make sure you have the right tools.
Tools.
I feel like this summarizes it a little bit better than that. Okay, so make sure you have the right tools. You have the title, you have the units, you have the axes labeled, and you have the axes scale. You have to make sure you have those features. All four of them. I think for the most part we're pretty strong on that, but make sure if you ever make a graph on the AP exam, you hit all four of those. The AP exam doesn't regularly make you make graphs, but it does do it every now and then. It mostly has you focus on analyzing the graphs. So if you are creating a graph, make sure you have the right tools.
Tools.
Make sure you have the right tools.
I'm gonna use a tall pen to cheat on this test.
Go for it, go for it. Okay? So
Let
again,
him forget scale axis.
I would make sure, I would use a segmented bar chart here, but do notice, so his tick, 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 that's the scaling of the axes, right? Make sure you use an equal interval all the way through, and then you label your axes. Do create a key if you need to. But title, units, which please make sure you, I guess he labels the units, but label your axes, scale your axes, okay? This is a good note. You don't need bar values on the AP exam like this. They just show it for clarity, because you can see if you've scaled it well, roughly what it is. It doesn't have to be perfect, it doesn't have to be exact. That's one of the things I love about statistics is you don't have to be super duper like, it's exactly 55.234. Like, no, I can estimate it, okay? So what do we notice? We already talked about it. More men apply, but at the same time, they are admitted at an even higher rate. Women are at a lower rate. So let's look further into the admission rate. So conditional distributions. I need you to hold on and pay attention to these conditional distributions because this is going to tie into the most difficult unit for most students, probability. It doesn't have to be. Listen, trust me. Probability doesn't have to be difficult. And I'm going to try to restructure things to make it easier this year. But traditionally, students have found the most difficulty with it, okay? But this is the starting point. And I need you to pay attention to this because you learn this now. It's going to help things really well.
Why would it be the most difficult?
The probability, because we learn probabilities you've not heard of before.
So when are we gonna learn this unit? Cause I need it before my next ACT.
We will
This class
learn,
is
so
not
we're doing
ACTs
one
not
variable
a thing.
statistics right now. And I might combine this with what's called normal distributions, which is also one variable statistics. And I think probability, if I remember correctly, is the
So will we
unit
get
right
to that
after
before April?
Yes.
It's before the midterm.
We will get to sampling distributions before the end of this 9 weeks, which is the unit and a half after probability.
Wowza.
That'll put us halfway through the course, yeah.
What's the hardest topic?
It's up to every student.
To you.
But generally, from what you see.
Let me think on it. I also don't want to tell you it's the most difficult, like I shouldn't even said probability, I just want to set us up well. Alright, so the admit rate for each gender. So what we're going to do is, we're going to find a conditional distribution by gender. A lot of y'all did this well on the notes, but I want us to think about this. What was the admittance rate for males? Notice, what condition am I setting?
Male applicants.
I'm looking only at male applicants, right? So what was the admission rate for male applicants? Well, I'm not looking at everybody, I'm just looking at males, so what is this out of?
1,190.
Well, that's how many were admitted, right?
No, I meant like at the top.
Okay,
Yeah. Divide by 2691.
so I only want to know of males, and of those males, how many were
Admitted.
admitted? Notice, in this case, I have set a condition. Am I looking at everybody? No, I'm not looking at the percent of admitted males. I'm looking at of the males, what were admitted. Okay? Now, that's it. So we set a condition. I'm not looking at everyone, I'm only looking at males. When we say conditional, I'm not looking at everything, I'm just looking at that condition. That becomes my new total. Okay? Does that make sense? Help the conditional make sense? Okay? And so notice you can get a percent. I do want to make a quick note to students, or to all of you. If I ask for a proportion, do not put 44.5%. That's not a proportion, what is that? That's a percent, okay? What would the proportion be? Anybody know how we would report that?
0.445.
So there's two options. You can do 0.445, right? The decimal version or the fraction version. One thing I love about the Inspires, pick it up for me. Type in 1198 divided by 2691. Don't get the decimal, just 1198 divided by 2691.
I don't know. Wait,
Is it
I
down?
might, but it might not be.
Isn't it
I mean,
like
I could go
a
grab
dot?
mine.
It'll
Don't do that right now. Just 1198 divided by 2691.
1198 divided by 2.
And
It's the same.
It's exactly the same. So that means that this does not simplify. On the AP exam, you can just write the fraction or you can get the decimal. That's the proportion. Either of these would be acceptable for the proportion or the probability. Okay? Notice I had you do it because let's just say you were to type 9/12 into that calculator. Type 9/12 in.
304.
So these calculators will simplify fractions for you. You don't have to do it by hand, right? And then, Brayden, you are correct. If you put a decimal somewhere in there, it'll automatically make it a decimal. But you can do just be aware, not asking for percentages, asking for the proportions usually. So the rejection rate then is 55.5%. So 45% of all males are admitted, 55% are rejected. Let's look at females. Now we're going to do the same thing for the females. Notice, looking at it this way, does it appear like there is gender discrimination?
I can't see.
Yes.
To a degree, yeah.
Yes.
Not just to a degree. What percent of males were admitted?
44.5.
Almost half, but 45%. What percent of the females were? Not even a full third, but 30%, right? I say it because a full third would be 33%. So you tell me, does it look like there's gender discrimination in the acceptance rate?
Yes.
Why do you say it like that?
But what if there's a gap in like their individual?
intelligence.
By that degree?
Yeah.
Yeah,
So
you
men are
think,
smarter
you
than
think that
Well,
there's
no,
a
that's
discrimination gap between
discrimination.
all men and all women?
Yeah, well, Berkeley's are more like. they're
Go ahead,
more-
say it.
they
So
focus
are you
more-
trying to say that men are smarter than women in the
No.
1970s?
I'm saying.
Call it out.
I mean,
it's
it's
not
not to
to
fight you, I'm
There's
just
a reason
saying.
I
why,
am.
like,
Figure out what you have to
MIT
say first.
undergrads are like Asian, you know?
Uh,
That's not
This is
discrimination.
not wrong.
Is it discrimination or is it a gap in their individual talents?
It's
Well,
not
he kind of does have a point, because
Yeah.
it's been 1973, and like, I'm pretty sure women couldn't even have credit cards then, or just started to be able to do that.
So-
Like, maybe that can
It's
balance.
possible.
Maybe women were just less educated back then.
That's fair.
So
back
notice,
then.
maybe it's not that they were less
Yep.
intelligent, but maybe they did get less
Back in the good old
education,
days.
right? We talked about the gender
Women are
gap in
crazy.
STEM, right? The gender gap in STEM, is it because of hiring discrimination or is it because of socialization? Who knows? But there's actually a more interesting factor at play here. So let's actually look more at this data. Because I will say this. If you are a woman in the 1970s, you have to, for the most part, be an exceptional woman to even be applying to UC Berkeley. So that's the thing of caution for me, where it's like, these women more than likely are next level, so why are they still being accepted at a lower rate? So I'm with Jaden. If we're talking about the whole population of all women, that's quite possible. But the applicant pool of women to UC Berkeley would probably be the best of the best. So, oh yeah, here's segmented bar charts. Notice,
Their campus is nice.
this is exactly what I would have done. Segmented bar charts specifically are really good for anything that adds up to 100% and conditional probabilities. Okay, so segmented bar charts, great for conditional probabilities. Gross, you just use the right tools. So is there evidence of an association between gender and admission rates?
Yeah.
Yeah.
Yes, right? Remember when we talk about association, what did we put in the notes? What did y'all write in your notes about identifying association?
It's like something if you change variable, then that variable, hold on.
So if we change gender, does that affect the other variable of admission rate?
Yes.
Okay, so that's what we want to recognize. Is there an association? Yes. Males are admitted at a higher rate than females. Notice we're looking at those conditional probabilities. Not just overall admissions, but at those conditional probabilities. So if we change from male to
How
female,
about you?
females have a lower rate of admission.
Fair enough.
Okay. So do the data suggest an association? We already said the answer is yes, but let's look further at it. So translation, yeah, do admission rates differ between the two groups? Yes. Alright, I do want you to make a quick note of this because I think that this from Ms. Youngshaver is a really, really good way to say this. If you are asked about an association on the AP exam, or just in general in real life, you need to make a claim first. There is or is not an association. You gotta make a claim, right? After that, you need to support your claim by comparing the percentages. Actually compare the percentages between the groups. And what do you always have to include in statistics?
Data.
Statistics.
Context.
Yeah, that's the percentages. We gotta have what? Context. Like, don't just tell me, and I'll put this back up in a second. Don't just tell me that 44.5% is higher than 34.4%.
That's true.
It is true, yeah, but that's not good statistics. 44.5% of the males were admitted to UC Berkeley, which is greater than, notice how I'm comparing, the 30.4% of females who were admitted. Notice, I made a claim, there is an association, I compared the percentages, and I included the context. You gotta have all three, because it's the real world. We're talking about the real world. Make sure there's context. In statistics, don't ever leave your context out.
That's BS.
Yeah, that's bad statistics. You tell them. Alright. See, Jaden's still writing a little bit. Michael's writing, so I'll wait a second. Nate.
Peter.
Sorry, I couldn't see Peter through
Oh,
Michael.
Serena, that handwriting looks really bad.
At least I can read it. Mm-hmm.
Only you.
I can read Peter's handwriting pretty well.
No. Yeah, he has girl's handwriting.
You have chicken scratch.
I do, but like whatever.
That's
You
what's
mean
the
he has
word?
pretty handwriting
What's
that I
the
can
word for
read?
that?
No.
Oh no, the villainy.
No, Miss Dennis is like, some girl left her paper here, like it has no name.
Oh.
That's Peter's.
Dang.
That is pretty funny. Okay. So don't forget, when asked about an association,
Hey, that just means you
make
have
a
to
claim,
writing, exactly.
compare percentages, include context. I will also, please note, you don't have to write every single word down.
Yours
Make sure you have the big ideas. So, I do like, I don't like this. Don't say higher or lower, it's greater than, or it's less than, or it's similar to, right? Use standard thing. Can you say higher or lower? Sure, I'm just gonna say greater than or less than.
Hypertonic,
But-
hypotonic.
There we go.
Isotonic.
So gender and admission rates are associated. In particular, women are admitted at a lower rate than men. Context, comparison, there is an association. Okay.
Yay.
All right.
It was so
So,
quiet.
here's an important part of it though. And so I'm going to introduce a new concept and something I want you to hear, because sometimes looking at the aggregate data, meaning all of the data together, doesn't tell the full story. And so this is not just for the AP exam, this is for understanding statistics. Because they dove into this data a little bit deeper. Don't just take the shallow observations to be 100%. Because there's an interesting story. Graduate school admissions, they don't make that at the whole UC Berkeley level. They make it based on each department, right? So the College of Education gets their say, the College of Engineering gets their say, right? Each department gets to look at it. And so, yeah, history department, biology department run their own admissions. And so what the team ended up trying to do is trying to figure out, hey, which of these departments was actually the biggest problem? Which one was more discriminatory? And so what they did is they looked at the different departments, and if the department had a 51 to 100% admittance rate, they said it was not a selective department. If the admission rate was between 26 and 50%, they were selective. And if the rate was 1 to 25%, it was very, very selective, right? And so here's how they broke that data down. We looked at this a little bit more. And so in the not selective, right, 865 people were admitted, 520 were rejected. We see it here, notice that's less than half but more than 25%, and that's even less than 25%. But still, 2,691 applicants, okay? So those are the admittance rates for those different departments. And so here, sorry, that was male applicants. I was like, that's not right, 100%. There we go. That was just the male applicants. So the male applicants, 865 were admitted out of 1385. So a lot of them applied to not very selective departments. 258 out of 742, 75 out of 564 for all of the males. Whereas the females, so that's their admittance rates, whereas the females applied to the not selective here, and they had a huge chunk admitted into here, didn't they?
Uh-huh.
And then in the selective, they had a good bit, and then in the very selective, they had that many. So we have a little bit different story. Interesting.
More females are applying to harder to get into departments.
Oh. Yeah, because when I look back here at the males, at the not very selective, 62.5%, right? The women were accepted at a higher rate. At the selective, they were hired at almost the same rate. And at the very selective, which I think it comes back up in a second, they were accepted at a higher rate. So more women were what?
More women were applying to harder, like the non-selective groups.
Oh, so was there actually acceptance bias here based on gender?
No.
No. I'm going to explain what this is called in a second, but I'm super glad, yeah, I knew it was right there, I should have just gone ahead. I'm super glad you picked up on it, right? When we look here, and I think it comes back up, hold on a second, let me check. Yeah, let's go back. When we look here, only 133 of the 1,835 women applied to the easy departments. Only 133 of them. Whereas over half, well over half of the men applied to the really easy departments. So it's just more women are applying for the harder stuff.
This is still at Berkeley, right?
This was at
Yes.
Berkeley in 1973 specifically, not today.
Uh,
Yeah.
No, I meant like the past one was Berkeley, so I was wondering.
Yes,
This is the same study.
No, this is the same study.
Oh, exact same?
Yeah. If you remember, we had 1,835 women earlier, and we had 2,691 men earlier. Yeah, this is the same exact study. This was them diving deeper into the data. That's why I said, you can't just look at the aggregate data, all of it. You need to dive into the pieces of it. Okay, so what Serena was noticing is, yeah, the women were at a higher rate there, about the same here, and higher there, but the women were, and so that created this situation where more men overall were admitted. So this is something called Simpson's paradox.
Herman?
What is Homer doing here?
Like
The paradox is
Not Homer Simpson. Okay? Simpson's paradox. When we look at the overall data, it looks like men are what?
Being accepted at a high rate.
Yeah, it looks like men are being favored when I look at the overall data, doesn't it? But when I look at the breakdown this way, who's actually getting a better admittance rate?
Women.
Women, right? So it's when the overall data shows some kind of story that is different than the breakdown. And again, it always happens because someone is doing something at a harder situation. Like I remember looking at this situation where we compared two hospitals. And one of the hospitals you would say, I would never go there because I want to say like the mortality rate was like 50 to 60%, whereas the other mortality rate was something like 30 to 40%. You're like, well, I want to go to the 30 to 40% one. But what actually ended up happening was that the one that had a lower mortality rate also just had a whole lot of easier and more mild cases, whereas the one that had a higher mortality rate had a way higher rate of people coming in who were already almost dead. And so it looks like they were doing a terrible job of taking care of them, but when you broke the data down, they were actually doing a better job with both the really ill and the ones with mild cases. So you have to break the data down. You can't just take that surface level. So overall, within each department, women were actually coming out ahead
Oh yeah.
because of Simpson's paradox, which is why you got to dive into the data. And you also need to understand conditional probabilities. Because notice, we're not looking at overall data, we are looking at the admissions rates given they were in a not selective department. Given that they were in a selective department, right? So we broke it down on those conditions. So across the departments, female admittance rates is higher or roughly equal. So what makes the overall admit rate lower for women? Well, it was that idea right here. This is where a mosaic plot is phenomenal. Please notice, right here is why women had a lower admissions rate. Because even though they had a really high admissions rate right here, did many of them apply here?
No.
They much higher rate applied to these areas. You would not be able to see this story in a traditional segmented bar graph. A mosaic plot shows us the story in both variables, both the admissions rates, but also proportionally how selective of departments they were being applied, they were applying into. The men were taking the easy way out, so they got a higher admission rate. Essentially, was what it was. Okay, so you can see here when we talk about who I need to. Don't let me forget to do attendance. I haven't shown you how to do attendance yet, have I? Okay, remind me to do that later because I haven't done it yet.
Is it on
They're gonna
PowerSchool?
let me soon. Yeah, it's on
I
PowerSchool.
don't know how to then, I did
Okay. Well, but I still have to use the slides, so
Yeah.
we'll figure it out. Okay, please notice over half of the men though went into the easier departments, whereas an itty bitty bit of the women went into the easier departments. Does this help explain conditional probability and mosaic plots a little bit better?
Yeah.
Okay.
It's cool.
So it's just telling the multiple pieces of data all at once. What questions do you have though before I continue from mosaic plots? I'm gonna let you mull over that for a minute while I do attendance.
Look, I second. Mosaic, like the mosaic period. I'm looking at mosaic.
Okay, I need to clean this up so you just like you just. So I'm already gonna hardwired in.
We stack it up to 100.
It's also.
Would you just send it to the
I guess it's their school figure.
All.
That's my guess.
What is it? I guess a segment is just one variable.
That's
Yeah.
just,
bar graph.
that's just a, girl, what do you mean?
Yeah.
Yeah.
I just
I'm just
wonder.
saying it has blocks and like graphs.
That makes sense. That was
Is it-
So what do you mean? So
Was that
like,
necessary?
why does it not have a percent number at the top here?
No, like on the side, why is it not, are you, it's pretty obvious.
Well, so notice they created a key here. So they put the units here, but because they created a key, they didn't have to put admission decision over there as well. They created a key that represented that. Good question, good question. Oh, here we go. This is good to note. These plots were created using Statlet.com. There's a good resource, Statlet.com, to make
Is it
mosaic
free?
plots. Huh?
Is it free?
Yeah, I've actually heard of Statlet before, and that is free. I need to look to see if you can make, I don't know why I didn't think about this earlier, CodeApp is an app as well that I think has mosaic plots. I'll look at it for free resources. It's called CodeApp. It's C-O-D-A-P, I don't remember exactly what it all stands for, but it's good. Anyways, so notice mosaic plot, same as the segmented bar graph, but bar widths are scaled by the sample size, so it's proportional. Notice, does it have to be perfect?
No.
No, but it does tell a big story. On top of that, I will note the area is an important part of this. Notice how there's just a bigger area through here.
Bro's ready. We lock in.
So, yeah, log in like you haven't already been logged in. So again, mosaic plots. Did y'all come up with any questions that you had before? No, we good? Lonnie, you good? You sure?
Fine.
You're fine, or you good?
I'm good.
Okay. So there's the men versus women. And it's exactly what Serena noticed from the beginning, right? Why was the admittance rate for women lower? Not because they weren't accepted really at as high of a rate, they just applied to more difficult departments. Okay. James is jelly because he didn't notice that first. What?
That's what
Nothing.
Bro's
Alright.
like, no.
Huh?
I was voting for the photos.
So,
All.
here are the questions from the textbook that would be useful, but I will say the Skew the Script has some homework problems in there that would be really productive for this. You don't have a solution key yet for them, but I'll work on a solution key and give them to you tomorrow.
Is that printed in our like normal notes somewhere?
It's right here.
Right here.
Where?
You're
It's
on
on
the
page
page.
Homework one.
Where?
Yeah.
It's at the bottom of page 2, I believe.
Oh, it's right there.
Yes, it is.
It's,
That's what I thought.
what are you-
All.
My question is like not following along with.
Huh?
No.
Not following along with.
Go for it.
I'm trying to like,
Oh,
like you have like
I knew
some
that.
slides, it's just like words and they're not really.
Well, that's because I went through that one quickly. I'll slow down when we get to other stuff. But like, are you looking for pages in Skew the Script?
Yeah.
Is what you're
there were,
asking?
like some pages where it was like you had like context of it.
Dude, we have these like weird little.
Oh, I know what you're
Yeah,
talking
don't
about.
sweat.
Dialysis.
Yeah,
Dude.
we've done those.
I'm just showing some things.
They're
But
so
the main
nasty,
thing
and you
is,
have to like reach
like,
in and like
these
grab like
packages-
a
I
mule.
use the spoon.
Alright.
Use the spoon.
Oh, I
Uh,
didn't grab it.
All right.
I was not doing that.
so that's it for
Intestines,
categorical variables
chickens.
and representing categorical variables. What are the main things we need to know out of representing
Okay,
categorical
so-
variables?
All.
What do we need to pull out of the categorical variables lesson there? We need to know what type of graphs.
Bar graph, mosaic.
Bar graphs,
Two
Segment,
table.
Segment.
Tools.
well, so we need to know tools all the time, right? If we're trying to make a graph, make sure you use the right tools,
High
okay?
chart.
But we need to know the graphs of segmented bar charts, comparative bar charts,
Histogram.
mosaic plots, not
Wait,
yet.
histograms is.
We're gonna talk about
That's
histograms in a
not-
minute.
That's not.
The we
Yeah,
have two
comparative
High
are just
charts.
when you have two bars.
High chart.
So like,
factor
remember how we
table.
looked at all, the overall admission rate, maybe?
Yeah,
or-
they had like
and
they had
then-
the 4 and they were kind of like that. Yeah.
Yeah, so it's 2 and 2, that's comparative.
Oh, wait, really?
Yeah, I want this.
Right now?
Alright,
We need
and
to-
then guys, y'all need to know, oh, we didn't talk about it actually earlier, joint probability. What do I
Oh, yeah,
mean
this
by joint probability?
That one thing that's
This
illegal
and
here,
that.
but it's like, it's legalized in some places, like medically.
That's not,
What?
it's not joint
That's
relative
not the
frequency,
right joint.
You knew that wasn't what I was asking. So, alright, so let me ask this. So if I were to ask you, what is the likelihood that someone was admitted, or that a female was admitted? Can you help Sanaya out? She's on the struggle bus right there. What's the likelihood that someone was admitted? Yeah.
What is this called?
I'm asking, what is the likelihood that a woman was admitted? Because these are all the female applicants, right? I don't need the number, or I don't need the actual decimal, just tell me what the fraction will be.
557 over 1835.
1835. So we looked at the what here? That is the
Total admittance.
total, yes, but there's an M word that I'm looking for here.
Marginal.
I'm looking at the margins, right? So this is what type of relative frequency? Marginal relative frequency. Noted all I looked at was admitted. Okay? If it's in the margins, it's marginal relative frequency. Okay? If I were to ask you, what is the likelihood that of these female applicants, they were admitted to a selective department?
333 out of 1835.
Notice how that includes two variables. I looked at both admitted and at selective. One way to see this is, here's all of my admitted, right? There's all the admitted. And here is all of my selective. And this is where they join together,
It looks like a bottle cap.
right? See how that's where they join together though? So you know what I'm going to call that? Joint probabilities or joint relative frequencies.
I understand it now.
Okay, so joint is because it's where they join together. Those two variables join together. If it's only one variable, it's in the margins, it's marginal relative frequency. And if I were to ask, I see your hand, I'll get to it in just a second. If I were to ask you, what is the relative frequency that, let's see, what am I trying to say? Relative frequency of being admitted to a selective program or selective department. Am I now looking at everybody? Wait, hold on. Admitted to, given, applied, given they applied to a selective department.
Males or females?
Well, we only have females right here.
You gotta specify.
Well, it is. It's about content.
Yeah, it's about context.
So relative frequency of being admitted, given they applied to a selective department. Am I looking at everybody now? What has to be true? What condition is there?
Admitted and only applied to selective department, so it'd be 333 out of 968.
So what was the condition though?
Applied to a selective.
They had to have applied to a selective department, right? That's a condition that has to be satisfied. So I'm no longer looking at all 1,835, I'm only looking at my selective. And of those selective, how many were admitted? Okay, so that's the idea of a conditional. I just want to drive that home. Marginal, joint, and conditional, you got to know those three terms. And conditional is just, hey, this one thing has to be true first. I'm only looking at the selective departments. Good with that?
Indubitably.
All right, indubitably. Glad to hear. All right. We're gonna quickly, probably finish up graphs today for quantitative, which means tomorrow after the test, we get to jump into analyzing those quantitative variables. So,
How long do we have on the test?
general rule of thumb on the AP exam, 2¼ minutes per multiple choice and roughly 13 minutes per free response. not that long tomorrow though, because it is 1 unit only. So 2 minutes of multiple choice per multiple choice question. And then I'm gonna say either 11 or 12 minutes, I'm gonna play with it and see how we're doing per free response. So it's gonna be a total of a maximum of 40 minutes.
You should do it at the end of class so you can stay after school if you need to.
I would rather do the full, because here's the thing, on the 8, I'll talk to people maybe, but on the actual AP exam, you're not gonna be able to stay after on the AP exam.
Never know. I'll just
No,
go
you
back
do.
to section.
You do, you and I both do, okay. So, we gotta know our types of variables. We are about to talk about histograms, dot plots, stem and leaf plots. Don't let me forget the comparative, the back-to-back.
Plots.
There's some benefits to them.
What?
And a cumulative graph.
They're good.
We're gonna get into, representing the data, that's the foundation, so that we can start talking about these target pieces of the types of graphs. We did pretty well with that from what I remember.
Can't wait to go home.
Alright. So this is actually something good that we're going to use out of the traditional notes that I've used in the past. So this is on page 3. Please turn to that. This is going to help us understand how we analyze our data well. Page 3 from our notes. Pages. Okay?
Where are you at?
To help some of y'all stay awake a little bit better, it'll be after all the UC Berkeley stuff.
Where's page 3?
Oh my god, my eyes.
It says page 3 at the bottom.
It's right there.
Oh, I got it. Without any help, you know.
Oh, okay.
Without-
Oh, okay.
It'll be before that. Okay? So yeah, I know you got skew the script stuff mixed in. No. I think you rearranged.
I had to
Oh wait,
poke holes in my potatoes.
you may have rearranged things.
Sorry, what page is it?
3.
3. Oh, duh. What page does it look like?
Oh.
Oh, it has like the dots all over it.
Okay, it has a million dots on it like this, guys.
This is the one that we skipped.
Indubitably.
That is
I
not-
don't know, I tried to keep them in order when I printed them out.
Yeah, it's the one that says.
Huh?
That's my answer.
Oh my
Oh,
god.
no pencil in there.
Yeah, we're about to finish up.
This is not
Oh,
good.
crap.
No, this is not, unit 2 is not on the test tomorrow.
K or S.
Just the unit 1 stuff.
Yes.
Yes.
So one.
Okay, alright.
Don't mess those.
You found the
I
dots.
had it
Alright,
figured out.
so let's look at this set of dots right here. Question 1, and I'm going to give y'all, we're going to do it question by question and bring it back together every minute or so. So, question 1 just says, what is the most important difference between cities A, B, and C? What I will say is I want y'all to talk with each other for about a minute. Just look at cities A, B, and C and figure out what the difference is. One thing I will point out is the context is Brian and Jessica have decided to move and are considering 7 different cities, A through, what is this, F? Something like that. The dot plots below show the daily high temperatures in June, July, and August. So there's a dot for each day. Help them pick a city by answering the questions below. So look at cities A, B, and C. What's the biggest difference between those 3 cities for their temperatures in those months? You got 60 seconds starting now.
Do we have to write it down?
I mean, you can write it down in a minute. We're going to talk about it though as well. So when you say range, what do you mean?
Like the lowest and the
Like-
highest are in different places.
Yeah.
So be careful when we say range in statistics. Range is only the difference between the max and the min.
The
So is
distribution.
the difference between the max and the min different?
The diffusion is different.
Diffusion.
I don't know what's going
This is
on.
The median
This
is in
is not
different
biased.
places.
Oh, the median.
I
Oh,
understand it
that's
now.
smart.
Real
Okay.
cooked. Real cooked.
I understand it now.
Okay, yes.
What are you thinking?
Oh, I said,
Look how much I crashed out. Okay, so you need to
Oh my.
No.
Pay attention.
Look again at your dots. Look again at your dots. You see that group of 3 columns right there?
Yeah.
Doesn't that look the same as this?
Why did he crash out?
Yeah,
That's-
same as that one.
What's that for?
Oh, they look exactly the same.
For the
so what's
weather
the
day,
difference?
and she was like,
Oh, yeah,
crashing
they
out.
Dudes.
There's no high and low.
Besides the fact that like,
Wait, I didn't even
obviously
know.
Jabber in the middle.
Oh my god.
Oh, the middle is
The mean.
different.
Honestly, I finished the whole
It could
semester
be
like an
mean, or it
hour.
could be median, you could
Median.
also
Do you
say
have bonus points though?
center.
Yeah,
I
so
didn't
check.
Nah, you wrote-
I don't think I care about my grades that much.
Oh, so someone
You're
wrote
right.
lower numbers temperature?
No,
Okay,
no.
you're right.
So
I
let's bring
stopped
it back.
caring.
Number 1. What is the
As
biggest
long as it's
difference
the
here?
A.
The median.
The median, some other people have talked about the mean, right? Now, here's one thing I want you to be aware of on the AP exam. If you don't actually know what the mean is, or you don't actually know what the median is, you can make some kind of inferences. But do you know a term that we use over that's kind of general to talk about the mean or the median? Okay, so average is only just a mean.
Wait, I got this
There's a
wrong.
C word that you might have seen. Yeah, the measures of center.
Oh my god.
When we talk about our mean and our median, we're talking about measures of center. Okay? So, what is the most important difference? The centers of the distribution. Those are huge differences. Now, when we say center, and we're going to go into this more later, but when we say center, we mean either mean or median. Does anyone know the other measure of center that we don't actually use in statistics very often? The mode is the other measure of center, right? It's just the most
I never
frequent.
learned
We
what
don't
this
use it
means.
very often. Okay?
So
So the centers of those distributions are different. In fact, I actually talked about with Braden how different were the actual graphs other than the centers.
They are the exact same.
They are the exact same graph. If you actually look into it, it's the exact same points in each of these little regions. It's just the centers are different. That's it.
Lazy.
Okay?
Yes.
And no, it drove home a point. And it does bring up this point really quickly, okay? I want to talk about something that Peter was saying with his group, which ended up being about the center, but this is important, where, I mean,
Oh
he
my
was,
God.
it's good to learn from it, okay? So, he was talking about the range of these being different. In statistics, though, do you know how we actually calculate range? So it is the maximum value minus the minimum value. So when you talk about range in mathematics, you report the range in math as a minimum, comma, a maximum, right? Using that interval notation, that look familiar?
Yeah.
But that's not what range is in statistics. The range is a single number. It is the value that is the max minus the min. So like, I'm gonna estimate here, but, dude, that was terrible.
Is that not funny?
No.
This is educational space.
Okay, so that's roughly 78, I'm gonna say that that's 104. So the range here is, what's 104 minus 78, 86? No.
Get
26 is
out.
100.
Quick math.
Okay,
86.
so what's the range here?
Uh-uh.
What's the range here? 26, and what's the range here?
26.
So you see how the range is exactly the same, okay?
Indubitably.
Because we're not doing lowest to highest. The range, the maximum minus the minimum, is exactly the same. Okay, and so the only differences were the measure of center. Now I want you to do number 2. I want you to look at cities C and D, and I want you to think about, hey, what is the most important difference between C and D? You got 60 seconds.
C is
Range.
The range is obviously.
The range is very different, isn't
Yeah,
it?
that was a
D
lot
is
longer.
unimodal and D
Shut
is
up.
Is C unimodal and D is unimodal?
I said D is uniform.
Oh, uniform. Close.
What do you mean
Whatever.
close?
I wouldn't have considered that one quite uniform. We'll talk about this in a second.
Variability.
I'll show it there.
doesn't work.
But if you look,
Whoa.
it kind of peaks a little bit and then it flattens back out. Notice it is a little bit lower. I'm not saying you're wrong. I just wouldn't have quite said it.
That's kind of what my question was yesterday, actually. Like, how do you know, like, when those peaks are actually considered peaks?
I got you.
How do you say?
Oh yeah, that's
It will
true.
be very clear.
I know, but, like, is there a way to calculate? I know it's not needed, but, like,
You just have to see it.
There's no way to really calculate. You just have to see
see
it.
pictures. Serena, I did not consent to those pictures.
Alright,
I'm trying to get a picture.
so bringing it back, what is the most important difference between C and D? So the range, do you know what the range is a measure of though?
Variability.
Variability, there's a term you said though, Lana. Spread, okay?
This isn't my.
So the range is a measure of variability or spread. The variability or the spread there is the biggest difference. What I would even point out is, I want you to note, if I kind of put the center there, doesn't the center look about the same for both of them? It's not perfect, because, real world data is not perfect, but the only real difference between C and D is how spread out that data is. Just hear me on this. The range is only one measure of spread or one measure of variability, and we're usually not going to use it. Range is usually the worst measure of spread.
Yeah.
We'll talk about why when we get there tomorrow. Say again.
Well,
There's something called standard deviation, and then there's something called the interquartile range, which is a significantly better one. So we'll talk about it then. Yeah, we'll get there. We will still use range, by the way, because it's an easy one, but it's just, there's something called resistant and non-resistant measures,
Yeah.
and we'll talk about what that means, but
What'd you
it's
make?
important. Okay,
I may try.
1 more minute. What are the important differences between D and E? So now we're looking at these,
Good for him.
okay? So D and E, what are the differences there?
Okay, well, you have some outliers.
Oh.
It has the exact
I
same.
care about you. I care about you.
The peak is, wait, is the peak the
I
difference?
see.
What is it?
They have the exact same range, but these.
I mean, the range, yeah, the range is the same.
Compared to the fact that the
So,
average
Each
is
of those
not.
didn't just.
you don't
just
know that they're
cater-
outliers,
I mean, I
but
guess in
they are
either the-
potentially outliers.
I'd say
Measure
that
center.
average.
Wait, no, wait, never
Two
mind.
dots. all the way
Standard
here,
deviation.
and then
Are they kind of outside of what we expect?
Yeah.
Okay.
How do you see
It
the
says
difference?
range obviously doesn't apply.
Because it's way higher than that one.
Okay.
Average.
So-
I mean, but they might be the same because.
Jaden, what was your
people
initial
have
jump to
outside.
be the difference here? What did you initially say? Is that what you said first?
I didn't say the range.
Oh my god.
You said what?
I said the meta.
I could have sworn you said the
The
range,
median and
but,
the range are the same.
okay, do note the ranges are exactly the what?
Same.
The same.
Identical.
So Braden, what were you thinking was the difference between D and E?
Here.
That's almost like the average temperature, or the fact that those are outliers, or potentially
Look.
outliers.
Okay, so we are gonna study how to actually determine if a point is an outlier or not. Until you actually do the calculations to determine if it's an outlier, we can only say a potential outlier, okay? So we have potential outliers in city E. Another thing I would say, yes, Jaden?
Don't you like subtract each data point from the mean?
Oh
Then
my.
No.
Hold on, dude, we'll get there.
Then you add them, then you spread them, then you spread root it, then you.
You're talking about standard deviation.
Is that part of it?
Chill,
Oh.
Is that
that's part of it.
Actually.
Bro, like
You know
does
what?
prior research and then just like brings it up.
Do you see all of this right here though, where we basically like kind of jump from one data point like to a really far away data point? We would also call that a gap. Okay, so on potential outliers and gaps in our data, these are these are known as our unusual aspects. So if we are analyzing data, we want to always acknowledge unusual aspects. All right, I'm going to bring all of these things together in an acronym to help us remember these things. Yes,
Why would those two dots be included?
what do you mean?
Why are they there?
I mean, because those were the high temperatures in June and July. So apparently one day for this city, there was a 60-degree high, and for this one, there was a 100-something degree high, but also it's made up data to help you see something. Yeah. It's to help me talk about unusual aspects. That's why those two data points are there. All right.
Nerd.
So last thing down here, we're looking at cities E through G. No,
CFG.
CFG, thank you. We're looking at C, F, and G. What's the differences between those?
Those are obviously skewed.
Which ones are skewed?
F and G are skewed. F
Okay.
is skewed.
So when we say skewed, that means something specific in statistics. It's only what we're seeing here. So first off, what's C if it's not skewed? It is?
Unimodal.
It is unimodal, but look again at these. Are these unimodal?
Yeah,
Is
they
there
are
one B?
Uniform.
Shoot.
So
Wait, no,
uniform
no.
means it's the same all the way across.
What is it? What does it start with?
Symmetric.
Thank you. Now, however, I will say this, in statistics, we won't actually say symmetric, we will say roughly or approximately symmetric.
Then why is it in the notes as symmetric? Excuse me?
Say again?
Why is it in the notes as symmetric then?
Oh, she got you there.
It's roughly symmetric. Okay, alright. So here's the thing though, is it perfectly
Oh my
symmetric?
God.
No.
Nothing in
looks like it to
statistics
me.
is perfect. That's what I do want you to hear me on. Nothing in statistics is perfect. Data is always messy. So we would say, yes, it's unimodal, more it's the fact that it's roughly symmetric, right? And then some of us were talking about skewed. Do you know what this city would be? What type of skewness we would see here?
Skew.
skewed
Black.
right. Okay?
Can't even know you listen right.
Because the tail's longer on the
The
right.
tail. Please hear me. This is a detail a lot of students miss out on, but skewness refers to the longer tail.
It does?
Yes.
Yeah. Accurate.
Oh crap. Man, this is double whammy. I don't even know what else to write.
Okay? So, skewness refers to the longer tail. So this would be skewed right here. And what would the last one be?
Skewed left.
Skewed left. Pay attention to which direction the tail is. People always want to think about that hump, but when something is skewed, it's throwing things off, isn't it?
Yeah.
This is the center, this is where the median is. This is skewing the data to the left, right? Having these really low values is skewing that data to
See,
the
I can't even
left.
notice when I was taking notes.
So it is
because I thought it
skewed
was-
left. We good with that?
Because you're just drawing random
It's
shapes.
easy enough?
No,
You're
I
looking
looked
at
it
me,
up.
but
I
you're not
entered
saying
it.
yes. You good? You sure?
Isn't it text?
You wanna ask a question? Can I help you, please?
What is your writer?
Huh?
I did there
For the ambassador thing tonight,
Huh?
I don't have
Jaden,
a
you
small
good?
like little hair tie
Yeah.
though, so I'm gonna like look on the fourth one.
Alright,
Ew. That's nasty.
so
Where that?
all of this, to summarize this, guys, hear me clearly on this. When you analyze data,
I mean, I can't go home, so I gotta do it again.
so to
Wait, you're
analyze
staying here?
I
data,
have to do theater.
there will
So
be
you're changing-
different,
Yeah, I did it after like
Oh,
in
is it open
rehearsal one
house?
time.
Is it open
You're
house?
doing like
Yeah.
a date?
Oh.
Like
Yeah,
last
100%.
year.
Say fours.
Huh?
Michael, Serena,
Yeah.
need all focus. Some sources, like I think Young Shave was Skew the Script uses socks. I learned it a different way that is to me more fun to say. So to analyze data, cuss it in context.
There you go.
You're not- Don't cut.
He loves his acronyms.
I do. So cuss, what do you think that C stands for? It's something up here.
Center.
It's the center. When we say C, we mean center. What do you think this U stands for? Something up here.
Unusual.
Uniform.
That's our unusual accent.
I can't think more. I actually can't.
And we have two S's. What do you think that S's refer to?
Skew.
So skew ties into the shape. When we say one of the S's ties into shape, and so it could be skewed or it could be symmetric. Hold on a second. But also shape refers to unimodal, uniform, or bimodal. Okay? So we are cussing our data in context, and then the last S was what, Serena?
Spread.
Spread.
I don't wanna
And we
cuss
will
anything.
learn about those different measures of spread and measures of center over the next couple days.
Ooh, cussing.
So to analyze your data, cuss that joker in context. Identify the center, the unusual aspects, the shape, and the
Oh.
spread. Okay?
Not too
So we
much.
have to cuss in stats.
100%. Cuss all the time.
Okay.
Okay.
Say less.
No,
In context.
See, now the
Yeah, but
person
it's
is
only
wrong.
allowed if it's in context, Michael. Let's clarify.
but you said you can
The
cuss in
context is
class.
Serena's
You had
annoying.
context earlier when you said,
The context
Yeah,
is
let's
Peter's
not.
big
Let's
fat
not.
holes are laying all over
Okay. So right here, this is where we are
This is so
moving to,
unfair.
back to 1.3, describing quantitative data. So one thing, by the way, is we haven't actually talked a lot about mean or median. When we say center at this point, we could have just said, hey, the center is about blank. Like that's something valid for AP statistics. When we start getting more into mean and median, we can be more specific. But
Reference.
here is
Oh my gosh,
the
I
case
love
of
it.
Moneyball.
Armstrong.
This is a really good context, which is why I'm using this lesson. If you've ever seen it, this guy used data analytics and statistics to build the ultimate cheap baseball team that did a phenomenal job. So we're going to look at this data.
I watched Fight Club for the first time.
You mean Brad Pitt? Oh, Jonah Hill was in it. And Philip Seymour Hoffman. I forgot about that.
Saying I can't read.
So, no. I was like, that's Brad Pitt. I just saw you looking at a picture. Jonah Hill was one of the data analysts, I think, if I remember correctly.
No, that makes sense.
Yeah.
This class is actually something serious.
Alright, so in the 2002 baseball season, the Yankees scored the most run. Boo, Yankees, they suck.
My brother wears a
That's
hat that has
kind of
something
cute.
on it.
What?
I'm a huge Yankees fan.
Ew, gross. Alright, anyway, so the Yankees scored the most runs. The Braves had the largest division lead. The Angels won the championship, but the dark
They stole our
horse.
A.
Huh?
They stole our
Man, it's
A.
mirrored.
They stole our A.
The Braves are cooler.
Anyways, the key now, or why would anyone then make this movie about the Oakland A's? So here's what happened. So we're going to use the data from this to talk about these different graphs. By the way, this is the acronym he uses. CSOX, context, shape, I don't remember, outliers maybe. Cussing in context is way more fun. Alright, so I'm about to actually send you all this data. Okay, so if you look right here, the Oakland A's spent $40 million that year. So they were one of the lowest in terms of spending money. This is why I don't like the Yankees. Right here. Why do they win? Because they spend tons of money. Congratulations. They're the
That's like
Mountain
the
Brook
National
of
Honor
baseball,
Society
right?
club.
Like, you got lots of money. We got it.
So it's his life.
It's like a savior.
Okay, same difference, right? I was like,
Very. Vestavia has more money than like
okay,
everybody else
it's
combined.
more like Vestavia. I'm so sorry, okay? So,
Vestavia has like a US military
Girl has something
budget.
against us.
alright, so the New York Yankees spent $126 million, the Oakland A's spent $40 million, and so here's their payroll done as a what? Dot plot, right? I'm gonna actually show you tomorrow how to use these calculators to make dot plots and make other graphs, because these calculators are really powerful. By the way, moving forward, starting from this unit on, if I were you, I would take one of these calculators home each night because it will help you with doing a lot of the statistics, and I have enough in here that the 9 of y'all can borrow one, and I still have enough for
If only you didn't get that
my other
Casio.
classes. Okay, so there's our
I got
payroll.
the Casio a year ago.
Is garbage, tick, whatever, just make sure you have the tools. So we have the Oakland A's only spent $40 million. Here's another, really quickly, this is something I always pay attention to. Dot plot, what's the advantage? We can see every data point. What is another reason that a dot plot is a good graph? You know what it is? It's really easy. You just put dots on there, right? We've used dot plots already this year. Dot plots, you can see every data point. They're really easy, but it is harder to see each point's exact value. Do you know what graph y'all have used where you can see each individual's exact value?
No.
It's one of the three. Not a histogram.
Wait.
Stem plot.
Okay, remember on a stem plot where you actually had to put the actual individual numbers in there?
Yeah.
So what's one of the few graphs
That's
you
why
can
stem
see
plots are
each
cool.
exact value?
Stem
A
plot.
stem plot, I'm still personally never going to use a stem plot in my everyday life. It's on the AP exam though. But what's the issue with a dot plot?
There's gaps, and that's one.
Well,
Gaps aren't terrible.
when you have a really big range, it really sucks.
Yeah.
Hey guys, if you had 1,000 dots to put on there, do you want to make that dot plot?
That's a job for
No.
Serena.
That's a job for Serena.
Oh yeah.
I would say don't
Or
get
Michael when he's my
Oh, no,
TA.
never again. You gotta get
So,
down for that. I don't
dot
know.
plots is you can see all the data values on a full scale, but you don't know the exact values, and it could be a lot for the data set. All right. So how can we see it? We already talked about all that.
Do you still have those menus?
I do. I'm gonna have to. Miss Kowalski's gonna help me make them.
Oh, that's
Um,
horrible.
Volunteer hours.
Okay.
If I can
At the
help.
end,
Oh, wait,
my
I wanna
hands
help
just
her up.
felt
Hey,
like-
really
Hours
quickly.
total.
Hey guys, last couple of details right here on
Valid
page
count
4
points.
before the bell catches us. I want to talk about this. So we already talked about, and we have that in there. This page 4 in the notes, how do you describe a distribution of a quantitative variable? If you've ever asked to describe a quantitative variable, what's the acronym I already gave you? CUS in
I should have done it. In
In what?
context.
context. Now I need you to pay attention to this part here though. What if you were asked to compare two distributions? You're still going to CUS in context, but you know what else you have to do?
Okay.
You have to, when we say compare, what are you going to have to use?
Data points.
Yes, but what kind of words do you have to use when you compare?
Explicit.
Explicit words like,
Prove them less than.
thank you, there we go, comparative words.
Explicit,
So,
oh my god.
Cuss,
So we have to use explicit words while cussing?
that's
No,
exactly.
we have to cuss explicitly.
Oh, I hate that now.
With explicit comparisons. With explicit comparisons.
Formal classes.
We'll pick up from here
Who
tomorrow.
doesn't know like a
And
this is like class.
what do we have tomorrow to finish? What are we taking tomorrow?
Yeah.
So cousin context with explicit comparisons.